So Kp and Kc are equilibrium constants, and here we are going to discuss about how you will see relations when you multiply something in a reaction. For example, if we have taken SO2 plus half O2 gives SO3 and we have multiplied in the next reaction with 2. So it becomes 2SO2, O2 gives 2SO3. So if equilibrium constant for the first reaction was Kc, then equilibrium constant for the next reaction will be, because you have multiplied with 2, it was SO2 plus half O2 gives SO3, and we have multiplied with 2 the overall reaction, previous reaction. So what happens is the equilibrium constant for the new reaction equals to Kc to the power 2. If we have multiplied this reaction if we multiply by 3, let's say, so the whole overall value becomes, if you multiply this reaction by 3, then Kc dash will be Kc to the power 3. If you multiply this reaction by 1 by 3, the previous reaction, I am talking about the original reaction, if you multiply this by 1 by 3, then the new reaction after multiplication you get Kc dash will be Kc to the power 1 by 3. So if you multiply by 2, 3, 4, 1 by 3, 1 by 2, 2 by 3, so whatever you multiply, so the new reaction obtained will have Kc dash equals to Kc to the power of that number, whatever you multiply that reaction with. Alright, so this is what easy method calculation, right? Now sometimes you are asked unit of Kc, unit of Kc. So how you will see mole per liter, and put power delta Ng, right? And if unit of Kp is to be calculated, what you have to do is use atm or bar to the power delta Ng. Just remember delta Ng you should know, right? What is delta Ng? Delta Ng is total gaseous products, total moles of gaseous product minus total moles of gaseous reactant. For example, I'll show you N2 plus 3H2 gives you 2NH3. So what is delta Ng for this reaction is total total moles of gaseous product. So how many moles of gaseous product? 2. Total moles of gaseous reactant, 1 moles of nitrogen and 3 moles of hydrogen. So total is 4. So delta Ng is gaseous product moles 2 minus gaseous reactant moles 3 plus 1 4. So 2 minus 4, this is minus 2, right? So you have to put delta Ng minus 2, you will get the unit. If Kc mole per liter to the power delta Ng, for Kp atmosphere or bar to the power delta Ng. If this delta Ng comes out to be 0, this delta Ng is 0, then this unit of Kp or Kc becomes equals to 1. That means it becomes unitless. Nowadays, anyways, we have been taking Kp, Kc as unitless most of the time. But if somebody is asking you, then this is the easiest method to tell them unit equals to mole per liter delta Ng or atmosphere bar to the power delta Ng. I hope you understood this. Now, taking another example, we have H2 plus I2 gives you 2Hi. So, how you have to calculate equilibrium constant? You have to do two basic calculations. First, you take initial number of moles, whatever have been given, A moles of H2 and B moles of I2, and initial moles of Hi is 0. Then if X moles are getting reacted, so the remaining moles, number of moles of at equilibrium will be A minus X and B minus X for I2. Now you have to see the concentration of these reactants and products at equilibrium. So if it was 1 mole, it was 1 mole, 2 moles were formed. If X mole is reacting H2 and X moles of I2 is reacting, it will be formed 2x. So concentration of H2 at equilibrium will be moles of H2, that is A minus X, upon volume of the container, that is V. So H2 concentration is A minus X upon V. Similarly, concentration of I2 will be B minus X concentration of B, moles of B upon volume of container, right? And similarly, concentration of HI is moles of HI 2x upon V. Now apply the formula. You know how you write. You write product concentration raised to the power of their coefficient. Like here, concentration of HI to the power coefficient is 2. So we have put it at the power. Similarly, reactants are put at the bottom. H2 concentration into I2 concentration, both have coefficient 1 and 1. So power is 1 and 1. Now you take calculations, numbers are given in a question, apply this formula and you get the answer.